Hey there, friends. We're going to kind of dive a little bit deeper into inheritance and polymorphism today, and we're going to recap a little bit real fast. So remember, polymorphism is when we can create one specific type of object and store it in a more generic kind of reference. So we can take a student and we can store it as a person. Reminders that we can't do this the opposite direction, though, unfortunately, because not every person is guaranteed to be a student. So we want to make sure that the data type that we are constructing is following that is a relationship with the reference variable that we are storing it inside of. And again, we always want to look at the constructor to verify which object is actually created, because it can kind of take on many different quote-unquote masks, if you think of it that way, depending on what kind of data it is stored as. And when we call methods with polymorphic references, those variables that are really a person, they're kind of on the base level, look like a person, but maybe they're storing an actual student object in there. These method calls actually go through a pretty complex process to identify which exact specific method should be used. And so the type of the reference variable, the data that it's being stored as, has one aspect of this, and then the actual type of the object itself kind of determines which specific version of this is called. This always happens every time that we override some sort of a method, and we inherit some methods coming into our classes from these hierarchies. And again, it really all depends at the end of the day as to the two different things, as to what is it currently being stored as or referred to as, and what kind of object is it actually or was actually built. And so we're going to talk about this stuff called early binding versus late binding. There's a lot of kind of wordy explanations that we can kind of talk about. I think I've got a nice simple way of kind of explaining this, though. With early binding, we're really looking at what the reference variable is. What is this thing currently being stored as? And so in the example that we look at down here, this is currently being stored as a teacher, if you want to think of it that way. Technically, it is also a teacher object, but when I'm talking about the reference variable, I'm really talking about this left-hand side of the equal symbol that we're looking at. And what ends up happening here is, in early binding, your computer, when it compiles the code, it has to kind of determine whether or not some method calls are even valid. And so the first thing that happens during compile time is your computer is going to look at every object that's there and what it is currently being stored as or referred as. And what it will do is it will look in that specific class, and it will determine whether or not this method call is available. And so for the example that we have earlier, where if we build a student object on the right-hand side, but then we have some sort of a person on the left-hand side, the first thing that's going to happen is it's going to go to the person class, and it's going to kind of identify, hey, is this method available for a person object? If it is, I will compile. And this is really a nice way of double checking to verify that things can happen. So like, again, the computer just, at this point in time, early in the binding, just worries about, can this program even run right now? Well, there's also something called late binding. Late binding is actually when the program is running. And so when it's running, it might look at this and say, well, I know that the variable that we have is currently stored as one data type, but let me see what kind of object was actually created and what kind of object is technically actually stored in that variable, and let me see if they have a more specific version of that method to run. So for example, if we look down here at this very bottom line right here, we're going to assume the following is happening. First off, there's a slight system of hierarchy where we will have a person class and we will have some sort of a teacher class as well. What we can assume from this is, in this example at least, we will assume that the person class has a method called work, and we will assume that the teacher class has overridden that work method to do something specific. It does not matter whether this is a partial override or a complete override. It just is important that it is overridden in general. And so if you take a look at what's happening here, I have a teacher object that is being built, which is being stored as a person reference at this point in time. And so I want to walk through the early versus late binding of what's happening here. Below, you'll notice that it says, take whatever we have here and call the work method. Well, this comes down to which work method. Is it coming from the person class because technically it's being stored or referred to as a person right now? Or is this coming from the teacher class because that's the type of object that was created? It's actually doing both of these, if you think about it, in the early and late binding, and we'll talk about that right now. So early binding, what's going to happen? Early binding is going to take a look at the variable itself, and it's going to recognize that APCS is a person reference. And when it compiles, it's going to run down here and say, well, I have some sort of a person reference that is trying to call the method work. Is it possible for something from the person class to actually call that method? In this example, yes. We went over earlier that the person class does have a work method in there that it could call. Perfect. That's all early binding cares about. It comes through and says, will this code compile? Can it run sufficiently? Late binding, when the computer is actually running this program and it gets to this line of code right here, it's going to recognize that I've got this thing called APCS and I need to call the work method. But which version do I call? The first thing it is going to do is it is going to look at the type of object that was actually instantiated and created. In this case, a teacher object was actually built. So the first place it is going to go is it is going to go to that teacher class and see if it has a more specific, aka overridden version of that method. In this case, we talked about how the teacher class did have an overridden version of that work method, and therefore the teacher's version of that work method is the one that actually runs. And we've seen this earlier when we talked about this because we had that coding example where we had the animals, and all like a general animal had the ability to speak, but a cow and a pig both overrode that method. The first thing that kind of went through that looping mechanism is said, early binding said, hey, can an animal even speak? Of course it can. The speak method did exist in the animal class. But then when the code actually executed, we saw different outputs. And that was because late binding recognized that cows had a more specific version and pigs had a more specific version that was being ran itself. And this polymorphism, again, allows for so much flexibility in the code. It allows us to create an array of now several different types of objects that are all kind of consumed under this generic umbrella. And again, the generic umbrella would be something like a person or an animal. And inside of that, we could store students, high school students, teachers, workers. We could store pigs, cows, sheep, lamb. All of those things kind of fall into either the animal category or that person category. I do always like to bring up here, remember there is a top dog class called the object class. If you really wanted to, you could make an array of objects, and that array could technically hold any type of data that you wanted to, because in the world of Java, everything is an object. So that's something that we don't often see, but it's technically something that can be done at that point in time. But this also means at some point in time, it's really, really important to make sure we know what object was actually created. And this tends to happen or come into play a little bit later when we talk about casting. And so in this case, we know that all pigs are animals, but we don't always know the vice versa is true. And so take a look at this example that we have down here where I build some sort of a pig named Wilbur. I believe the true statement is whether it is kosher or something like that. And we store it as an animal reference. But really deep down, it's kind of being disguised as an animal. Is it illegal for me to take what I know is a pig and refer to it back as a pig? It's actually not. And we can verify this because we know a pig constructor was actually called. So casting can allow you to change reference data types, but you have to be extremely careful because you need to be verifying that that is actually the type of data that you have. Because P1 was technically constructed as a pig, I can take P1 and cast it into a pig and then store it as a pig reference. That is 100% allowed. If by chance you try to do this and it's incorrect, let's say, for example, I have the same exact line, but instead of saying new pig, it says new cow. So in this case, P1 would actually be a cow object. This line of code would fail. I cannot take what is technically a cow and cast it into a pig. This is when we would receive some sort of an error, and it typically is shown or displayed as a class cast exception for you. So again, we'll kind of verify this, and we'll run through some coding examples a little bit later to give you guys a concrete example of this. But in general, what we're kind of learning today, early binding, your computer's compiler is going to check and verify what are you currently being stored as. Can this method call be completed by that specific data type that it's being stored as? Late binding, as the program runs, let me go look and see what kind of data was actually instantiated. Let me see if there's a more specific version of that method in that class that I would like to run. Congratulations, polymorphism, and its amazing complexities.